Welcome to this lesson about equilibria. In this specific video, we're going to focus on KC, things that you should know from AS, but in A level, they're very important because the setup of the calculation is similar for KP. So you need to be confident with it. So Kc, for an homogeneous system where the reactants and products are in the same state, remember K is any equilibrium constant and is always calculated as whichever value you're considering of the products over the reactants. C stands for concentration. In fact, it would be the concentration of the products over the concentration of the reactants. Few points to notice. The bracket, the square bracket, it means concentration. And this concentration, they have to be at the power of their stoichiometric coefficient. Hence, this highlighted B. The important thing also to remember is that it's concentration. Okay? When you calculate the concentration, you do the equilibrium moles over the volume. So this is the tricky part. You need to calculate these equilibrium moles. And of course, do not forget any conversion in the volume. Silly mistakes that you wanted to prevent. So just notice. The units, they are specific for each equation. And just like any other equilibrium constant, you needed to cancel them out. So the unit of concentration is mole per decimeter cube. You can simplify it to cancel it out. In fact, I normally write it as this big M because it makes the canceling just a lot easier. You need to cancel out the repeating unit, top and bottom. You will notice that you have two concentration at the top and three at the bottom. These will leave out one at the top and one concentration unit at the bottom. You need to make sure that you write it as a linear unit, so you need to check the powers. In fact, 1 over the unit is the same as as to the power of minus 1. Then we can expand it as mole per decimeters cubed to the minus 1. So to solve this, it's mole minus 1 decimeters cubed. Said that, let's dive into the calculations. You can use this Rice table to find equilibrium moles. So Rice stands for reaction, initial, change, equilibrium moles. I would suggest you to always set it up this way. You have the reaction, and then by reading the exam question, you will be able to fill some things up in this table. So what you're given normally is the concentrations of the reactants. Unless stated clearly in the question, the initial moles, of the products are zero, unless stated. Remember, we're talking about moles. Then, as the reaction starts to take place, there is a change. It's decrease in an amount of reactants and increase in amounts of product. So this change follows the ratio. Important reactant decreases and product increases. With this, you can find the equilibrium moles by doing the value of your initial moles minus the value of the change. Why would be the opposite? This two should be here, but you would need to find the change. Yeah, while for the amount of products is the same as its change, unless you had an amount at the beginning. So the important point is that those are the moles. So if you have the volume, you need to calculate the concentration, and that's why we could write it in this way, where the equilibrium moles are as we found them before, and then divided by the volume. So here you need to be very careful in reading the question. So this is important for your KP calculations because don't worry yet about the pressures, but you always need to find the moles at equilibrium. Okay, and that's why sometimes in these very open questions, you may be asked to find the equilibrium moles before you go into the partial pressure and mole fraction calculations. But more on that in a further video.